Good morning, good afternoon, wherever you are in your day. Welcome to Online Learning with Mr. Harris for Wednesday, May 13th, Formal Geometry and Algebra 1. Glad that you are checking in virtually. Hope you and your family are well, staying healthy, staying sane, making the best of a challenging and unprecedented situation. So, yeah, heart goes out to all of you and your families. And that being said, let us dive into some math. Start with some overview. There we go. So do your math. Your salary will thank you for it. And do the best you can. So whatever part of all this works for you, you have credit. I just was texting with the student right before I started this. They said they were having some challenges with Khan. They put in what they thought was the right answer. Then they said it was wrong, and then they looked at the hints in the answer and they said it was the same thing, and it's hard for me to know that without seeing it. And yeah, if it's something like that, the main thing is that you're working on this. Keep chipping away. So do whatever you can on this material. So if you're having a challenge with the software, try something else. Restart, come back to it. Try material for next year, whatever it is. Just, it's great that you are doing the math. If you get stuck, reach out. Like I said, just texting with the student. There's the number, email as well, and then try and get 75%. But like back to these other two, no worries and keep chipping away what you can. If you do get stuck, screenshots would be awesome. That would help. And feel free to preview next year's course. We've been covering that every week or every lesson. That's pretty standard by now, but I'm glad that you are here and working on this stuff and do your best. And just keep chipping away at it. And then if you need help, reach out. It's really the main stuff. So that being said, let's just look at a couple of problems. So informal geometry first. Just want to show you a volume of a pyramid problem. So here's how you do the volume of a pyramid. This is actually from the hard copy that we sent home to students. So volume is 1/3 base area times the height. Okay, so the area of this base, because it is a rectangle, is going to be 21 times 22. And that is right here. So 1/3 of base area and the height. Height is obviously 35. So that would go in there. So then you just solve the problem and do the mechanical portion of this math. Do the multiplication and division. Multiply 21, 22, and 35. And then divide by 3. Multiplying by 1/3 is the same as dividing by 3. When you do that, you get 5,390 meters cubed. So that is an example of how to get volume for a pyramid. Pyramid, quite obviously, as you are aware from Egypt, goes to a point. A prism goes from a regular polygon to another regular polygon. So, yeah, there's one informal geometry example. And then there's also an example. Yeah, from the con. So volume of this rectangular prism. So volume is volume is base area times that. And the base area for this one is 4/5 times 4/3 or 4/3 times 4/5, however you choose to do that. 5/4. That's 4/3. Here. And the height is going to be 3/5. I'm going to take 3/5 and put it in for height. Now you could put this all in your calculator, multiply all across top, multiply all across the bottom, and then divide. I'm going to use a little canceling and reduce this thing. So 3/3, those are both going to turn to 1 and 1 because they cancel. 4/4, both going to turn to 1/1 because they cancel. And then 5 times 1 times 1 and 1 times 1 times 5 is 5/5. Or another way is those are both just going to cancel. And you are left with volume is 1 centimeter. And its volume, it's three-dimensional, so it would be cubed. So that's how you go about doing that kind of problem. That's taken right from the homework. So an example of volume of a pyramid and then a volume with fractions. So hopefully that helps you to do your assignments. And yeah, we will clear these drawings and move on to algebra assignment. All right, so these are again from the notes that I posted for the hard copy. So if you want the hard copy stuff, the notes are here. Or if you want the notes or PDFs of them, easily send those out. So solve this, and really we're just giving you another tool how to do these things. Solve them by factoring, and that's great. Sometimes we don't get nice integer answers, and so factoring is not going to be a possibility for us. Graphing will be a possibility for us most times. There's cases it won't. There's no solution, for example. And you can also get some decimals, which might be hard to derive. But long story short, we're just giving another tool, another way to solve problem. So solve by factoring right here. Diamond it, set it equal to 0, set each piece equal to 0, x is 3 and x is 1. So those are the solutions. We can also just graph it. So this is a review from what you did earlier. I found 3 is C is the y-intercept, so I went ahead and graphed that. I looked for the axis of symmetry or the line of symmetry. Negative B over 2A. And so negative 4 over 2 times 1 is 2. So there is x equals 2 to the line of symmetry, which has a little dash there. Vertex has to be on the line of symmetry because it's the maximum point, and there's only one vertex. And so I'm going to take 2, and I'm going to plug it into the equation, and that is what's happened here. So 2 squared minus 4 times 2 plus 3, or 4 minus 8 plus 3 is -1. So the vertex is 2, -1, right there. So I have a vertex, I have this intercept point. I'm going to use symmetry to get another point. I know it's 2 units to the line of symmetry going horizontally here. So I know that there's going to be another point 2 units. The line of symmetry has the same thing on one side that it has on the other by definition. So there's a couple points. Where's it going to cross? I can sketch and kind of think I might know. I already should know because I could factor this one, so I do know it's going to cross at 1 and 3, but I'll go ahead and plug 1 in just to make sure. So I plugged 1 in here, 1 squared minus 4 times 1 plus 3. Do a plug and chug there, therefore 1 comma 0, because it does equal 0, it's going to be that point, so there's that point right there. Then again, using symmetry, it's 1 unit from that point to the line of symmetry horizontally. It's going to be 1 unit horizontally from the line of symmetry to the other point. So there you go. Those are the 2 solutions where it hits the x-axis, which is the same thing we got here. Y is 0, right? Y is 0. So yeah, show you 2 ways to solve a quadratic. All right, so that is that one. Here's another example. So first thing I did was I knew it hit at 18, so I knew it was going to be way up here somewhere. So I think I did that later, but I at least knew in my head it was going to kind of hit up here. And then the minus a tells me it's going to be slope down like this. When a is positive, it's upward curve, and when a is negative, it's downward curve. It's like an umbrella. A is positive, like a couplable, or however you want to think about it. So plug that in the equation. Or no, I guess I did the line of symmetry. So negative b over 2a, so minus 3 over 2 times -1. Negative 1.5, so you can kind of see it, but dashed line at negative 1.5. Put that in to find the vertex. Negative 1.5, squared it, multiplied by -3. Did the math here, 24 3/4. Boom, so I'm there. I know there's going to be another point over here. So I'm kind of getting some information, but I'm not exactly sure. And then I was like, well, can I factor this? So yeah, I changed all the signs because there's a negative there. So I hit the whole thing with a -1 to change it to that. And now I just factor it, x plus 6, x minus 3. So it looks like it's going to hit at -6 and 3. So now if I kind of have my vertex, have my sketch, that's what that could look like. And then I plugged it in to check it. You're totally free on problems like this to plug it into the graphing calculator. So if we were to plug something like this into a graphing calculator, can do this. Yes, if we change this to, this is just an online one I've got, negative x squared minus 3x plus 18. So there it is. That kind of looks like our picture. There's negative 6, 0, and there's 3 comma 0. So that matches what we got on our hand-drawn picture and matches what we got by factoring. So I feel it's pretty safe saying that was the correct answer. Okay, so there's a couple different ways to deal with that. And how does that apply to a count problem? Oh, so glad you hypothetically asked. So how this applies to a count problem. Antoine stands on a balcony and throws a ball to his dog. Well, dangerous. Who is at the ground, but whatever. We'll see if we can sort that out. So there's the equation. I think I can just factor this. The ball's height each second. So when will the ball hit the ground? How many seconds I should throw the ball hit the ground? So when the ball hits the ground, the height's going to be 0, right? For all of these parabolas, and you're going to get some kind of effect like this, right? Where this would be the ground. Let's undo that. This would be the ground right here. You throw something, and there's the force of gravity in the world that we can't escape. So kind of take off and then come down. In this case, we're on a balcony, so we'd start like up here somewhere. Right, if we're on the balcony, go down and come down. So the height will be 0 when it hits the ground. So I'm going to go ahead and change that to 0 and try and solve this thing. So 0 is negative 2 squared plus 4x plus 16. And I'm not even going to graph it because I look at this and I think if I factor out a negative 2, I'm going to be in a pretty good spot. So I'm going to go ahead and do that. X squared minus 2x minus 8. And then I'm going to go negative 2 x minus 4 x plus 3. All of that is going to equal 0. So I plug it in there, I'll get a negative time. So I'm not really concerned about that because I know I'm starting up on a balcony. I want to get the positive time out here. This will be h, right? And this will be time. Pretty classic problem. For parabolic flight, you get this in physics, which is really applied mathematics. And yeah, so I'm not worried about getting the -2. I am going to get this to be x is +4. So I think the time will be 4 seconds. And before I do put my answer in to that, I would, again, go to a graphing calculator. And the one I've been showing you is just this Desmos thing. I just Googled how to do that. I just Googled graphing calculator and got this Desmos thing. So let's plug it in. -2x squared plus 4x. So if I look at here is like where it starts, where it reaches its height, throw it off the balcony here, and it comes down, and it looks like it hit. It's going to hit that 4 seconds, which is what we got algebraically by factoring it. So that's another way to do it with the graphing, and we got -2 as well. But we're not concerned about that because he's on this balcony and going forward. Yeah, so I hope that helps you with that problem. Let's stop. Yeah, there you go. So I hope that helps with that problem. The answer was 4. Keep chipping away and doing what you're doing. If you have questions, reach out. And the most important thing for you to work on this material and stay healthy and stay balanced. So keep that up and just keep trying to get better at math as you do this. So that being said, I will see you guys next week with more mathematics. All right.